once again, I welcome you to my lesson for today, where we'll be looking at physical sciences. As you can see over there, we've got a nicely drawn diagram of which it forms part of our lesson for today. Sorry, so I just wanted to check, guys. You remember that I've sent a screenshot in the group of this question. Are you able to click somewhere where you're able to go back and click on that text that I've sent where I highlighted where this question paper is? Because I want you to be looking at what I'll be reading. Obviously, I've got that statement written over there, and also on my other phone, I've got that question paper. So are you guys able to see where is that question paper in the group?
No, sir.
Guys, are you able to see where is that question paper in the group?
No.
Yes.
Oh, no.
Are you there? You're not able to find it in the group? On your screen, click, you got it. Did all of you guys get that question paper?
Yes, sir.
Okay, 100%. So I'm just going to quickly read through the given statement, and from there, we'll go through the question. So question 3, it reads as follows. A hovering rescue helicopter has a container of supplies with a weight of 1,960 newtons hanging from a cable. The tension in the cable is a 2,100 Newton. So remember, guys, the cable is attached to both the container and again attached to the helicopter. So the container itself, they just said it has a weight of 1,960 Newton. Very, very much important, ladies and gentlemen. This is a force which is a vector quantity. Therefore, the direction is very much important. So that means this force is in the downwards direction. Why? Because it's the weight of that, the weight of that container. So the weight comes from this formula, guys. Remember, the weight is equals to mg, which is equals to 1,960 newtons in the downwards direction. So that means that amount of weight is as a result of the mass of that container with supplies, and again as a result of gravitational acceleration. And again, because the tension in the cable, because the cable, ladies and gentlemen, is attached to both an aeroplane, an helicopter, a rescue helicopter, and again attached to this a container with supplies. This container is not falling downwards because of it being attached to that the cable. So the tension in the cable, we are told, is 2,100 Newton. Ladies and gentlemen, force is a vector quantity, which means it has got directions. So in which direction is that tension, that cable, or the tension in the cable, as a result or in comparison with that container? It's obviously in the upward direction. So that means we've got a container over there, guys. We've got tension in that direction, which is 2,100 Newton. And again, we've got that, which is the weight, and it has a magnitude or a value of 1,960. So here comes a question, guys. These two forces, are they balanced? So an answer to that question should be a yes or a no.
No.
So if they are not balanced, it means if this container were to move, in which direction was it going to move?
Right side.
Which side, guys?
On the right side.
In that direction.
We're gonna move in the direction of the tension.
So whoever said in the right side, remember, guys, this container can only move up or down. That aeroplane is not moving sideways. It's not moving in that direction or in that direction. But they said a hovering rescue helicopter has a container of supplies, which is that container with a weight of that magnitude hanging from a cable. So that means that what is it? It means that container is hanging. Why is it hanging? Because it's held by that cable with a tension of that magnitude. So someone said these two forces are not balanced. And remember, guys, this is a force which is a force by tension. Let me just say force by tension or by the cable. Let me say this is force by the cable, which is called tension. So it's another type of a force. And again, this is a force as a result of weight or maybe as a result of gravitational acceleration or as a result of gravity. So this is what we call a weight. So why am I saying both of these are forces? Is because both of them are measured in newtons. So you just need to know the type of a force it is. But remember, guys, they did not say this container is moving up or is moving downwards. We were just told its weight is that much, and we have a force which is a tension of that much. Which means, guys, there is a force of force of friction, which is obviously in the opposite direction. What about this force of friction, guys? I'll just give an example. If you have an object which is being pulled upwards at a force of 5 Newton, but they are saying this object, its weight or its force, let's say, is 3 Newton. So they are not saying this object is moving up or down. In case if this object is not moving upwards and it's standing right there, it means there is a frictional force of 2 Newton. Why of 2 Newton? Is because it has to balance or counteract that force for it to remain stationary at that point. Otherwise, if there is no frictional force, that means this object is moving upwards. So what makes it to move upwards is because of there is more force pulling it in that direction than a force which is weighing it or pulling it in the downwards direction. So this is all the information that we know. As we read through the questions, that's when we'll be able to understand and know if there is a force of friction or not. So question 3.1, they say state Newton's first law of motion. This question is allocated 2 marks. So guys, is there someone who can quickly state that Newton's law?
So may I try?
Yes, you can give it a try.
Newton's first law of motion states that a body will remain in its state of rest or motion at a constant velocity unless a non-zero resultant or a net force acts upon it.
100%, which is something that you need to know at all times. Because when you are asked that question, an answer to that question, it doesn't change. So at all times when they say to you state Newton's first law of motion in words, you need to write it down as you got it from either the notes given by your teacher or otherwise as given by the textbook or whichever textbook that you're writing. So for that one, I won't go deep into it because it's just a straightforward question which you need to provide in order for you to score 2 marks. So now let's have a look at the second question. They say draw a labeled force diagram of all the forces acting on the container. So obviously, guys, if you are given this type of question where they want you to draw a labeled force diagram, and again, for the fact that this question is allocated 3 marks, I know very well that normally to indicate or represent one force, you are given just 1 mark. So this is an indication that we actually have 3 forces acting on that container. Remember, the question says draw a labeled force diagram of all the forces acting on the container. So you can either make a dot to represent the container, or otherwise you can just make a drawing similar to that to represent the container. First thing first, guys, indicate the forces given from the statement, which can also be seen on the given diagram. So obviously, we know there's a tension in that direction. Ladies and gentlemen, very, very much important that at all times, when you draw a labeled force diagram, you show the arrows. If you just make that line and say this is tension, you won't score maximum marks for that, ladies and gentlemen. You need to show that arrow in the upwards direction. And most importantly, write down to say this is tension, because if you just write that upwards arrow there, we are not sure if this is a force of friction, or we are not sure if it's the weight. So you need to label that a force to say the upward force is tension. And again, we've got another obvious force, guys, which is what is it? The weight. So you can just say this is the weight. You can just write a W over there. Again, let me see. Someone can still write. If you like, you can just say force as a result of gravity. I'm not sure if it makes sense, guys. Force as a result of a gravity. Remember, guys, a tension can also be referred to as force applied. So tension in the cable is the force applied to either move that container upwards or to keep it in position so that it does not move. So guys, I'm not sure if so far we are all on the same page, guys. All that I've explained so far, does it make sense, or is there someone who has got some questions?
Sam, yeah, I understand.
Okay, so remember guys, someone said these two forces are not balancing, and for that fact it means we've got a frictional force. Obviously, at all times, guys, force of friction is in the opposite direction of the force applied, which means if the force applied is in the upwards direction, that means force of friction will be in the downwards direction. Then you can just indicate over there to say this is the force of friction. So, ladies and gentlemen, otherwise, if you had to draw this on on that dot, you could have said you've got a positive a force, which is tension. Otherwise, someone can still say force applied. You will still get a mark. And again, you were going to have that force, which is the weight, or otherwise force as a result of gravity, and again a downwards arrow there to show force of friction. So the reason why I'm saying there is a frictional force or a force of friction is because already these two forces are not balancing. And for that fact, it means there is a frictional force. So guys, I think now we can then move to question 3.3. So this is how you'd score your 3 marks for that question of you drawing a labeled free body diagram. So guys, are we ready to move to the next question?
Sir, can I ask a question?
Mm-hmm.
If the doesn't balance, so there's no friction.
No. If the forces are not balancing, then it means there is a frictional force.
If it's balanced.
Oh, yes. If it's balanced, then it means there's no frictional force.
Thank you.
Okay, so 100%. So let's now move to question 3.3. So let's see, what does that question say? It says, why does the container remain stationary despite the tension being greater than the weight? So can you see, they are asking you, why does this container stay stationary? Remember, when it stays stationary, it means it's not moving upwards. So this thing is being pulled by that force of tension, which is 2,100 Newton. But the weight of this thing is only a, what is it, 1,960 Newton. So according to that explanation of this being pulled by 5 Newton, this being having a weight of 3 Newton, it means this thing, it is supposed to move upwards by an extra of 2 Newton. But instead, say it's not moving upwards, but is staying stationary at that same position. For it to stay there, it means there must be an extra 2 Newton so that it balances the force. And for that reason, it makes this a frictional force. So in answering that question, guys, it's because there is an extra downwards force. Does it make sense, guys?
No.
So yes.
100%. So that's how you would score yourself 2 marks for that question, just to indicate that is because there is an extra downwards force. So that means it's very, very much important to indicate that the extra force is in the downwards direction. Because if you just say there's an extra force, we are not sure if it's an extra upward force, which makes that to remain in its position. So now let's check question number 3.4. But before we get to 3.4, there's a statement given there. They say now the winch inside the helicopter starts to pull the container upwards with an acceleration of 0.13 meters per second squared, while the helicopter remains in its position. So can you see, guys? Something is now happening to that container. Remember, we've got that tension, we know we've got the weight, and again, we've got frictional force. But they are saying this thing is now starting to move upwards at an acceleration of 0.13 meters per second squared. So this is what we have been given by that statement over there. And again, they are saying that helicopter, it's not moving. So it is just stationary over there. So we shouldn't be confused to worry that much about that helicopter over there. We just know that this container is now moving upwards. So now let's check the question. They say 3.4, calculate the mass of the container. So guys, the mass of the container is what the question wants us to calculate. What is it that we know about the container? We know the weight of the container, guys, is equals to 1,960 Newton. What is the formula for the weight? It's M multiplied by what? By G, isn't it? So remember, guys, this question is allocated 2 marks. Now that we know the formula for calculating the weight of that container, it means we can use that same formula to answer the question because they want to know the mass of that container, which means we've got mg being equals to 1,960. Therefore, we know m is what we're trying to calculate. We know g is equals to 9.8. Then we can just substitute and calculate. Guys, what is the mass of that container?
It's 200 kg.
How did you get that answer? Who was it? How did you get the answer?
So I divided by 9.8 on both sides. Then on the left hand side, I was
So that means you divide by 9 over 8, 9.8, 9.8. So you're getting 200 kg. Ne?
Yes.
So remember, guys, mass is measured in kilograms. The SI unit for measuring the mass is in kilograms. So they are going to give you a mark for correct substitution and a mark for correct answer with the correct SI unit. So guys, did all of you understand that 3.4? I think it wasn't really that much complicated. Okay, so guys, let's now move to question 3.5, where the question says, calculate the magnitude of the tension in the cable while the container is being pulled upwards. So they want us to calculate the magnitude of the tension in the cable while the container is being pulled upwards. So guys, if we had this container, initially we had the tension in the cable as 2,100 Newton, and then we also had the weight of 1,960 Newton, and again we know we had a force of friction. And with all of this container was not moving, but now suddenly it's moving at that acceleration of, 0.13 meters per second squared. So the question is, the tension in the cable when this container moves, is it the same as that, or is it less, or is it greater? I'm talking about the tension. So guys, anyone to answer my question, or do you not understand my question, guys?
I think, sir, the tension that will calculate will be greater than the first tension.
A reason to that,
Sir, I am just guessing, sir. I don't have a reason.
okay, so you can say the reason to that is because when the tension is 2,100 Newton, this container, it's not moving, it won't move because it's being balanced by that and that. So for this container to move in the upwards direction, it means the tension has to increase. So that is why your answer has to be increased tension. So that means if this container moves in the downwards direction, then it means the tension is becoming less. Then you therefore have more force pulling downwards. So it's just a simple logic, guys. So in this case, my question is, what is the amount or the magnitude of the frictional force? Do we know what is the amount of the frictional force, or can we calculate it, and how can we calculate it?
Yes, so we can calculate it.
So what is it, or how can we calculate it?
It's going to be 2,100 minus 1,960. Then it's gonna be 140.
So that means the frictional force is 140 Newton. So let's now answer our question. So remember, guys, there's that formula which says F net is equals to mass times acceleration. So you can see from this formula that you need an acceleration for an object to move or change position. So what does F net mean? F net means force total. This is still the same as MA. What does force total mean? It means all the forces acting on a particular object, of which in this case the object is the container. So because force is a vector quantity, it therefore has a size or magnitude, and again it has direction. So you need to make an assumption. Normally we would say upwards being positive, then downwards being negative. Why do you have to do this? It's because a force, it's a vector quantity. It therefore has the magnitude or size, and again a direction. So now let's answer this question. Remember, guys, what they want us to calculate is the tension as this container moves up when it's being accelerated at that magnitude. So this is what you do. You would say a total forces, or F net, is equals to MA. How many forces do we have acting on that container, guys?
2.
3.
3. Oh, 3.
Yes, 3.
Okay, so we agree we've got 3. Which force is acting in the positive direction?
Tension.
Tension. Tension force.
So it's positive T. So remember, guys, total means you add everything, isn't it? Do you agree with me on that one?
Yes.
Yes.
So that means what other force are we supposed to add?
The force of gravity.
Which is the weight, nay.
Yes.
What other force are we supposed to add?
Force of friction.
Force of friction, 100%. The whole of this is equals to MA. So you did not change anything from that original formula. All you did was just to write the forces, all the forces acting on that object. So now, tension, do we substitute it as a positive or a negative sign?
Positive.
Positive.
So that means it's positive 2,100. But before, wait, guys, remember, the tension is what the question wants us to calculate. So we cannot substitute 2,100 because someone said it's going to be a bigger value. So that means we are now going to have we can just call it tension number 2. So that means that one, it was more like it was tension number 1. So I'm not sure if you understand between tension 1 and 2. Do you now understand the difference between the two?
No, sir.
Okay, so remember, tension number 1, that's when this object is not moving. If you attended this lesson from the beginning, you'll remember that we indicated that the initial tension is 2,100 and is being balanced by that weight and this force of friction. So this object is not moving. Then as we were continuing with the questions, they said, now this container is moving at that acceleration. So for the fact that it's moving, I asked if the tension is going to be still the same or greater than or less than. They said it's going to be greater than. Why? Because now this object is moving. So because we notice we've got two tensions, where the first one, the container is not moving, and the second one, the container is moving. That's why I'm saying tension number one is equals to 2,100, which represents the tension where this thing is not accelerating. And we have tension number two, where that container is now accelerating. I'm not sure if it makes sense.
Yeah, it makes sense now, sir.
Okay, so that means tension number two is what we are trying to calculate. So plus, this is a plus from the formula where they say total. You know total means plus. You know net, the word net means plus. So total and net, this is represented by those signs. So always substitute in brackets. Force of gravity, do we substitute as a plus or a minus?
Minus.
So it's going to be minus, what is it? It's minus 1960, isn't it?
Yes, sir.
100% plus into force of friction. Do we substitute it as a minus or a positive?
Minus.
Minus.
So that means we've got a minus 140, which is equals to. Do we know what is the mass?
Yes,
Yes.
it's
What is the mass?
200 kg.
So we calculated it from the previous question is 200. Do we know what is the acceleration?
Yes, given.
So the acceleration is given as 0.13. So obviously you can easily calculate tension number two. So guys, do you see why it's necessary to attend the maths lessons? It's because this is a great 8 stuff to solve. So obviously you've got all of that, which is 200 times 0.13, and then you transpose, you've got positive that 960, you still have positive 140, then it gives you an answer which is supposed to be in newtons. So I'm not sure if you guys are able to punch all of that and tell me what is the answer.
2,126.
So it's 2,126. Do we all agree with this answer?
Yes, sir.
100%, which means that extra tension, can you see? It's extra by 26. So this confirms that answer whereby we said this tension number two will have to increase. So now remember, this question was allocated, what was it? It was allocated 4 marks. So they are going to give you a mark for writing that correct formula, and again for correct substitution they are going to give you some marks, and again for correct final answer with the correct SI unit you are going to get a mark. Obviously, because we know tension is a vector quantity, we've given the magnitude and we've also indicated the direction. So guys, are you happy with this question?
Yes, sir.
100%. So now let's move to question number. I think this might be the last question, which is question number 3.6. They say, what will be, before we even get to that question, they say, after an acceleration of a few meters, the container is pulled up at a constant velocity of 0.8 meters per second. So remember, we've got that container, guys. We had our initial tension, let's say tension number 1, which was 2,100 Newton. And we had the weight, which was 1,960 Newton. We know we also had force of friction. So now, remember, we also had tension number 2, whereby this was 2,126, I think, Newton. So the other thing now is they are saying after an acceleration of a few meters, the container is pulled up at a constant velocity of 0.8 meters per second. 0.8 meters per second. So they are asking what will be the magnitude of the tension in the cable while the container moves upward at a constant velocity. So this is an interesting question, guys. This is a very interesting question. Remember, guys, we had our formula where we said we've got tension plus, what was it? Was it force as a result of gravity plus force as a result of friction? And this was equals to MA. But remember, guys, the formula for acceleration is equal to velocity final minus velocity initial over time. I'm sure you remember very well, guys. And again, for the fact that you've got a constant velocity, it makes acceleration to be 0. I'm not sure if you are aware of this thing that I'm saying. It's because let's say acceleration is equals to v final minus v initial divided by time. So if velocity is constant at 0.8, so that means final is the same as initial. So that means 0.8 minus 0.8 over time. Already, this thing at the top is 0. Whatever time that you divide with, it's going to be 0, which means 0 divided by anything is equals to 0. So that is the reason why when you have a constant velocity, your acceleration is going to be 0. Before I proceed, I'm not sure if you understand that part, ladies and gentlemen. Does it make sense?
Yes, sir.
Okay, so for that reason, I'm going to help you answer this question. Remember, what was the now, let's say we are calculating for tension number 3. Remember, this is just to differentiate the stages at which they are asking for or asking about the tension. So this is scenario number 3 where they are asking about the tension, which is where when it moves at that constant velocity. So tension number 3, obviously it's a plus over there. That one, it doesn't change. We know it's negative 1,960 plus that one, we know, what was it? Was it negative 140? Then this is equals to, guys, we know the mass is 200 grams. We know acceleration is 0. So that means tension number 3, if you subtract these two, if you say that minus that, it gives you, I think it's minus 2,100. And it's going to be equated to 200 times 0 is the same as 0. Which means tension for scenario number 3, it's going to be equals to transpose. Then you get positive 2,100 Newton. So that means when this container moves upwards at that constant velocity, the tension in the cable is that same value over there, which is 2,100. And this question was allocated only 1 mark. So you are going to get a mark for the final answer. But I had to show you by means of calculation how your final answer is 2,100. Ladies and gentlemen, I'm not sure if that makes any sense.
Yes, sir. It makes sense.
Does it make sense for everyone?
Yes, sir.
Ntando? Okay, so guys, I think since both of you have confirmed that it makes sense, it means it wasn't that much complicated. So ladies and gentlemen, thanks for joining today's lesson. I think I'll see you on our next lesson for tomorrow. So I'll just check what will be our next lesson. So guys, this brings us to the end of our lesson. Thanks very much for joining and have a good night.